All right, everybody, so here's the 2 word problems I promised you. First one says, as of January 2018, the world's tallest wind turbine was located, I can't say that, I think it's Geldorf, Germany, with a hub height of 178 meters and a rotor diameter of 137 meters. If the blades turn at a rate of 14 revolutions per minute, what is the linear speed of the blade tip in kilometers per hour? All right, so a lot of things here. First, this height, 178, does not matter. We're not going to use that, so it's just a fun fact. Then it says diameter is 137. So if the diameter is 137, and that was in meters, we have to find the radius by dividing by 2. So 137 over 2 gives us 68.5. And remember, it's still going to be in meters. So now we have the radius. The next thing we know is it does 14 revolutions per minute. Well, remember we talked about a circle, and we said every time you go all the way around, that's going to be 2 pi. So every revolution, 1 revolution, is 2 pi radians. I'm just going to read. So we have to think that we did 14 revolutions. So 14 revolutions would be 14 times 2, which is 28 pi radians. So I just multiplied. If you need to see that like differently, like if that doesn't like work for you, you can write it kind of as like unit analysis. So we can say 14 revolutions. And then you could say 1 revolution is 2 pi radians. So you could cancel the revolution with the revolution, and then you end up with 14 times 2 is 28 pi radians. So either way you get there is fine. I feel like if you looked at the Help Me Solve It View and Example, they would do this crossing out part. So I wanted to show it to you. Okay, so what do we know now? We know we have 28 pi radians. And we know that we have this radius that's equal to 16.5 meters. Let's go to another page because I feel like I have too much there. Remember, I gave you a few things in class. One of them was omega, and that was theta divided by time. Okay, well, we just found out our theta. It was how many revolutions do we have, and we said it was 28 pi. Revolutions are, right, we said it was 28 pi radians, and how much time did it take? If you go back and read it, it says it does it per minute. So it's important that you pay attention to the fact that this is per minute. So let's write per, where I'm going to write 1 minute underneath. Okay, so this is our speed. What did the question ask for? It said find the linear speed of the blade. Well, we had this V for linear speed, which we said initially was S over T. But then remember we changed that and we said, well, S is really theta times R. But then theta over T is omega. So we have omega times R. So here's my omega that we just found. So we found it was 28 pi radians per minute. I'm going to write 1 minute again. And then our radius, so if you go back and look, our radius was 68.5 and it was in meters. So this is 68.5 meters. I don't know why I have that line there, so I'm just going to put a 1 under it because I put it. All right, so we're kind of going in the right direction. The only thing you have to watch for is it said put your answer in kilometers per hour. So I need to do 2 conversions. I need to get rid of these meters. I need them to be kilometers. So to start that, I think, well, 1 kilometer is 1,000 meters. And then so now you can see the meters cancel. I have kilometers. I need to get rid of the minutes. So remember we have 60 minutes in 1 hour. So when you're going through this and you're trying to cancel things out, make sure they end up where you want them to be. So the minutes cancels the minutes. I have the hours now. I have kilometers. So I need to put all of this into my calculator. I will show me doing that. So I'm just going to do that in TI. So here's what I had. I had 28, and then pi is up over this up arrow. So there's 28 pi, and then times 68.5. And then we had times 1 over 1,000. So I'll do it that way, 1 divided by 1,000. And then we had times, I had 60 over 1, so they were getting it to my hours. Okay, so we end up with 361.53 is what I'm going to use. So 361.53.5, pay attention to what it says. It didn't say specifically in the textbook, which is where I took this problem, but it will say specifically in the homework how many decimal places to give. So I'm going to do 2. So we had 361.53 kilometers per hour. Next one says a spin balancer rotates the wheel of a car at 480 revolutions per minute if the diameter of the wheel is 26 inches. And it says what road speed is being tested. We're going to express our answer in miles per hour. There's a part 2. Then it says at how many revolutions per minute should the balancer be set to test a road speed of 80 miles per hour. We'll get to that. Let's start with this first part where we see 480 revolutions per minute. So 480, this is our revolutions per minute. Okay, this would be omega. It says how fast are we going? So how many revolutions and how long did it take? Now we learned in the last one, we don't want revolutions, we want this in terms of radians. So remember, we have 1 revolution is 2 pi radians. So now we're over into radians. So if you wanted to, you could just go ahead and do this one right now. When we do it, I'm going to write this as 960. I'm going to leave my pi, and this is still in terms of minutes, so I don't want to change that right now. As I continue reading, it says the diameter of the wheel is 26 inches. So just like last time, it gave diameter. We don't want diameter, we want radius. I do 26 over 2. That's 13, and this is in inches. So now we have our radius, we have our omega, we can start talking about speed. So speed, V, we saw in our last one, was omega times R. So it says, what speed are we testing? And we're like, well, we don't know. So what do we do know, though, is we had 960 pi radians per minute. And we have a radius that's 13 inches. Okay. The answer says it should be in miles per hour. So we need to get from inches to miles. Do it in little steps. There are 12 inches in 1 foot. There are 5,280 feet in 1 mile. Okay, so this took away inches, it took away feet, and my answer now is in miles. Here I have minutes. I don't want minutes. I want to have hours. So I do the opposite. I say 60 minutes, right? So I put it on top so it'll go away, and I say that's 1 hour. So now my minutes are also gone. So a lot of things to put in the calculator. I have 960 pi. I have 13, I have 1 over 12, I have 1 over 5,280, and I have 60. So again, I will show you what that looks like. 960 pi times 13 times 1 over 12 times 1 over 5,280, and then times 60. Altogether, that comes back at 37 point, I'm going to call it 13 this time. Okay, so let's remember that 37.13. So this says our speed is 36.13. And now our answer is in miles per hour. So this is miles per hour. So we answered the way they wanted to. Part 2 says, at how many revolutions per minute should the balancer be set to test a road speed of 80 miles per hour? Okay, so now this 80 miles an hour, this is V, right? This is V already, we know it. R is the same. R is still this 13 inches that we started with, but now we want to say, well, how fast does it need to go? So how many revolutions a minute do we need the tires to rotate? Okay. So we said V is 80. This is miles per hour. Our R was 13 inches. So we need to get to how many revolutions. So let's set this up as 80. I'm going to put the miles here and then an hour underneath. And then remember, we need omega times R, so R was 13 inches. So we need to get to what does omega need to be. So obviously I'm going to bring that 13 over. So I'm going to have 80, again, miles per hour. And I'm just going to say I'm dividing, so I'm going to write that as 1 over 13 inches. I want to keep track of like if things are on top or bottom and what is it. All right, we have this problem with miles and inches. So remember, we said there are 12 inches in 1 foot. There are 5,280 feet in 1 mile. This is getting us closer to the value of omega. So I won't show it this time because I've shown you a lot already. I'm going to do 80. I'm going to times by 1 over 13. And then I'm going to multiply by 12. And then I'm going to multiply by 5,280. I'm just going to give you the number I got in my calculator. So I got 389907.6923. Okay, what is this? Well, inches are gone with inches, feet are gone with feet, miles are gone with miles. So what is this? This is per hour. Okay. This is omega. So omega is looking at how many revolutions. Well, think about right now, we would be in radians. So our omega would be in radians, and we're trying to figure out, well, what would this omega be? This really tells me what's happening per hour, right? Because we're still in this hours, it didn't cross out. This is going to give me omega. Well, omega is theta over time. So we have to figure out, like, what is the theta? How many revolutions is it going to do in this 1 hour time that we have? If you remember back to earlier when we were doing this, it was in terms of minutes. So I'm just going to go ahead and change that over to minutes. That'll shrink our number a little. So we say there's 60 minutes in an hour. The hours are going to cancel out. So I have my 389907.6923 divided by 60. Now I have this 6498 point. I'm going to keep everything 461538. This gives me the radians per minute, and we don't want radians per minute. We would like to know revolutions. That's what the question asked for. So if this is radians, we have to say there are 2 pi r, 2 pi radians, not 2 pi r, 2 pi radians, sorry, per 1 revolution. Okay, so we get to shrink this number down a little bit more. So I'm going to take that number that I had, I'm going to divide by 2 pi. You may need to put the 2 pi in parentheses when you divide in your calculator, so know that ahead of time and make sure you try it. So now I got 1,034, I'm going to say 0.26 revolutions per minute. I know that's lengthy. It takes some time to get through. Give yourself plenty of time for the questions and the homework like this. Come back to the video if you need it. If you have questions, let me know.